which would usually be dedicated to just one purpose. Maybe it's just for audio. And that means it's not dependent upon external resources. So it's not dependent upon connecting to the internet. It's not dependent upon connecting to servers in the infrastructure. And we don't connect local area networks together through a router, typically in these networks, because that would be an external dependency. And where we see these most commonly deployed is where we have systems integrators, or indeed in live sound, a way of separating responsibilities from the AV systems integrator or the live sound production company from everything else. Sometimes living separately like this is politically easier, shall we say. The nice thing with doing a standalone network in a single LAN is we can forget about worrying about IP addresses. We can use this technique called automatic private IP addressing. That's what Microsoft call it, because we use Linux a lot. We've got a different name for it because in computing, often the same thing has many different names. So we call this linked local addressing. And the nice thing with this is it uses this special reserved network range, which is 169.254, and that's a 16-bit subnet. So the last 2 octets are floating. And that means we can have up to 65,536 individual IP addresses in this range. And the devices negotiate their own IP addresses automatically. You don't need to get involved. In fact, in the standard, it says that you should not assign static IP addresses in this range. Now, actually, the standard goes on to explain how you deal with that. And most implementations, you can do this safely, including our own. The other thing to remember is this particular range cannot pass through a router. Routers will just automatically ignore this and not pass this because it's non-routable address range. And that's quite deliberate. It's for computers to just come up and talk to each other in a standalone way. Now, people often get worried that the same IP address will be given to different devices. The standard for doing this is probably about 40 or 50 pages long. It's freely available on the internet if you want to look it up. But some of the stuff from the standard is quite interesting. If I have a network that's already very big, say if I have 1,500 devices, which I would not suggest having in a single network ever, but this is the mathematics side of it. When I add my 1,501st device to that network, the chances of getting a duplication is theoretically about 12%. The standard defines an algorithm that means you have to check the address you're about to use to see if anybody else is using it. If you get a response, you have to try again. So statistically, I try again a second time. My chance of getting a duplication on my second attempt is about 0.8%. If I have not got a unique address on a network that big by my 10th attempt, my suggestion would be to go and buy a lottery ticket and retire, because you're 168,000 times more likely to win the lottery than you are to take 10 attempts on this standard to get a unique address with 1,500 devices. So it's really, really, really safe. And with networks smaller than 200 devices, which is what we say about Dante, you're almost guaranteed to get a unique address straight away. And second attempts will be very fast anyway. So yeah, very, very, very safe way of assigning IP addresses automatically. And this is the default mode. When Dante comes up, it's out of the box. It will be working in this automatic IP address mode. When it automatically comes out of the box, it's also looking for a DHCP server, just in case there is one there. And that's in common with most modern operating systems. So indeed, Windows 10, by default, will look for a DHCP server, and if it doesn't find one, it will fall back to this very same method. So the key thing when we get people saying my Dante controller can't connect, it's because they've gone and put a static IP address into their computer. If you just leave it alone, it'll work. If you mess with it, well, you're taking responsibility for managing the network. And for most small networks, it just doesn't matter. I know I'm talking about this from a Dante audio perspective, and that's very convenient for me. And there are other systems that force you to use static IP addressing. Of course, I'm well aware of those. But if everything worked in this automatic way, like Windows, like Mac OS does, like Linux does, like Dante devices do, networking things together would be so much simpler. And the world's moving towards that incredibly slowly. I mean, this standard's only been around for nearly 30 years. It's not long. And these self-assigned IP addresses create a working local area network out of the box and almost immediately. So in summary from the networking section, Layer 3 networking allows us to use IP addresses for connections. As indeed was pointed out, this allows us to use discrete port numbers sitting on top of those IP addresses to have discrete audio channels and manage the mapping, so we're sending very efficient, very small bits of data. This is very, very common. Networks are not a new thing. They've been around for thousands of years in the form of postal and delivery networks. This thing we do where we have ports and IP addresses and MAC addresses, it's what we call encapsulation. So it's like if I write a letter, I put my letter inside the envelope, and hopefully the postman won't open my letter and read it. It's not his business. And the postman puts that into a mailbag and moves the mailbag around, and that's what we do with the network. So we put data from our ports into an IP address packet, and then we move that packet inside an Ethernet frame, like the mailbag, through the switches. So whilst the bag that the postman has when he's delivering the letters, that's a physical thing, that bag will be a unique bag when he gets to your street. It won't be the same container that was moved on the aeroplane for a long distance letter. And, if we're delivering within the same town, it will only go to the first switch, which would be the sorting office, and back out again. So that's the difference between the local area network and a wide area network. But our address format on a letter is universal. There's nothing to stop you writing a letter to me in the UK using exactly the same network. And that's the reason why we do it. We don't have to change our mind and use a different coloured van. We don't need to use a different sorting office. It's all the same common infrastructure because it's more efficient that way. And that's exactly replicated on data networks. Automatic addressing enables us to do plug-and-play networking and just concentrate on the important task of being sound engineers rather than network engineers. And standalone networks are used commonly to separate out different tasks and simplify responsibility and often avoid arguments. So we try to compress everything we do into one slide and try and define what Dante is. And this is really it. It's a hardware and software solution that transports precisely timed digital audio between devices using standard IP networking. That's what we do. Now, how we do it can change because technology keeps changing. The important thing, if you own an audio device, is that it keeps working and you can keep plugging it into things and it has a good long life. Because nobody likes to change technology every 5 minutes, throw away perfectly good audio equipment and replace it with other expensive audio equipment. So what we do is we do lots and lots of what we call regression testing. So we test back through different versions of firmware and different devices every time we do a new release. And so far, we can pass audio between devices we've created today and every single device ever created. So we're looking for long product life cycles here, which is what people want to buy. We don't want to magically just change our minds. So, for example, AES67 came along as a standard. People want to work with that. We shoved AES67 into the Dante solution. There's a button that says do AES67. We carry on doing classic Dante for those devices, and we can communicate AES67 at the same time, because that's what people want. And that means that with a new firmware version, people can put that into their devices and they can talk AES67, but it doesn't break anything behind. That's a really key thing for a technology. If we're going to be interoperable and plug into every single device, we have to try and keep that going for as long as possible. That's absolutely key to how we succeed. How we do that underneath in all the different detail, yes, of course, that changes day to day. So we get asked for solid specifications on things. I'm sure we all know that the danger of solid specifications is you publish them to the internet, that becomes a fact, and then when you change your mind and change the way you're doing stuff, even though it still works, people get these false notions about how it works, and that's been really bad. And in fact, we've never published exactly how we do certain things because we create that danger of bad information. So everybody who's told you how Dante works yet is not working inside Audinate, they're working outside, and they're trying to define things to do some kind of strange comparison. And often those comparisons are completely technically incorrect. I mean, they weren't even correct when they were written, and they're less correct even now. So just be careful of this comparative information. It's not necessarily meaningful, and it's not necessarily accurate either. So what we're doing from a user perspective, which is what matters, is we're using human readable names, because the whole point of IP networking, we all use IP networking for looking at the public internet. If we couldn't use human readable names on the public internet, it would not have got anywhere. I mean, my mum buys tickets to go and see the football. She goes on ManchesterUnited.com. If she had to look at Manchester United's IP address and type that in, she's not going to do that. The public internet would not have succeeded without DNS, the way of resolving names to computer-readable stuff. That was absolutely key to that. We use it in Dante networks, in both its forms. And that means we can name channel names, and they have a real meaning in the network, and we name devices. And we use either MDNS in the local area network, where that's a dynamic DNS paradigm where devices share information to resolve their names to their addresses, or we use standard DNS for wide area networks. And the nice thing with that is we can be flexible. The IP addresses don't matter, the MAC addresses don't matter. What matters is the name of the channel. And as sound engineers, that's what matters to us, yeah? We've all had multi-cores in our careers that have been a bit dodgy. So it says, I get the line list through from the front of house engineer, it says kick drum on channel 1. So I'm going to take channel 1 of my multi-core, I'm going to plug that into the kick drum microphone. Oh dear, it's buzzing. Help. Well, we all know what to do there. Unplug the channel, find a line that works off the other end. Oh, is that quiet? Right, we use that and repatch it. The front of house guy doesn't need to know that I'm not using cable number 1. He doesn't care. As long as it's coming up on channel 1 and that's the kick drum, happy. That's exactly how data networks should work. So if we change the name of the device, that's the thing that matters. If we keep the name of the device and change its IP address, that doesn't matter. It'll re-resolve back through. And if that buzzing IP address didn't work, we just change it. And that's really, really important for making things functional and robust. We precisely time align all of the audio. So everything in a Dante network is synchronous to within plus or minus 1 microsecond. So just to put that in context, we were talking about samples earlier. At 48 kilohertz, one sample is about 21 microseconds. So all of the devices are synchronous to within about 21st of a sample. So yes, when people say sample accurate, it's not just sample accurate, it's phase accurate as well. So yeah, really, really tight synchronization. We also deal with automatic device discovery. When we plug something in, it pops up in Dante Controller, and we can work with it just without worrying about typing in magic numbers. That's really important. And that gives us the ability to do one-click signal routing. That means we can just click between two devices and create relationships between them and create paths through the network. And the other key things, because we're working in live audio production environments, we need to have low and deterministic latencies. So Dante is a deterministic latency, virtually jitter-free in the audio spectrum, and we can automatically reconnect. So if the power goes off, when we bring the power back on, because the relationships and the patching is stored in all of the individual devices, they'll come back up and try and get hold of what they were listening to when they were last working. And that's really, really useful when we're working in environments where we might turn the power off, or we might have to move the device somewhere else and bring it back up. Nobody wants to go back into a big patching system and go, oh hell. I did have one guy ask me once, he said, I don't like this feature. Why? So, well, we're in a broadcast environment. What happens if someone forgets to clear the config on the stage box? Well, they'll soon learn. No, what I want you to do is I want you to build some software that can tell whether the device was turned off deliberately or not. That would be awesome. If I could make artificial intelligence to that quality, I wouldn't be working in audio. I'd have a robot trading shares for me. It would be brilliant. Unfortunately, we haven't got there yet. We've included this slide because sometimes we've had people say, oh, I've got this device plugged in and channel 1 is not coming up as channel 1. That's because oftentimes people put the Dante module into a system like this, where there's, say, in a mixing console, we have an input routing stage, which then will route the Dante inputs as well as analog inputs. We have the processing section, and then our output routing stage will decide which channel goes where. So just remember, on a lot of devices, you need to set the internal routing of the device as well as the external routing. Bandwidth, it's just a little comparison. So on a gigabit Ethernet link, we can happily move 512 channels in each direction. And when you start looking at how IP networks function, they really are like having lots of multi-cores around. So if you think about this, if I'm doing a link from my front of house console to the stage, I have a 1 gigabit link, I can send 512 audio channels from the stage to front of house. I might have another cable that's going to the monitor desk. I've got 512 channels available on that cable. They can be a different 512 channels to the ones I'm sending to front of house. I might go into the same switch. I can have a different cable going to my broadcast truck. Again, I can send a different 512 channels to the broadcast truck if I so wish. So it's just like having a whole bunch of multi-cores that come up in one space. Just because I've got 512 channels doesn't mean I have to send them all to everybody, because I've got something called a patch bay, or in this case a switch, with Dante controller managing the relationships on top. So this is a per link capacity, it's not a network wider capacity. And of course it's entirely bandwidth dependent. So I'm working on a project at the moment where they're using a lot more than 512 channels. So we put a 10 gig link in, it gives us 5,000 channels. Makes life a bit easier then. By comparison, MADI is constrained to 64 channels per cable, and the bandwidth can't change on MADI because it's part of the standard. On CobraNet, CobraNet on a 100 base Ethernet connection is typically 32 channels. There are vague improvements on it that can do otherwise. But ultimately with CobraNet, you would have to start doing things with VLANs to start using the bandwidth of a gigabit cable to actually take advantage of that stuff. And that becomes very, very complicated very, very quickly. Whereas we're just exposed directly to the backplane bandwidth of the network, and if it's available, we can use it for moving audio channels. So thinking about this, even a 64-channel console will only consume about 1/8 of the total capacity of a single gigabit port. So there's plenty of room around there for, watching Netflix if you wanted. Even though it's coming up the same cable to your switch, it's only going to use 8 megs of bandwidth. It's not going to get in the way of the audio data because we're not using all the capacity of the network. Now, whether you get fired for watching Netflix at front of house, that's kind of between you and your boss. Certainly in conferencing, yeah. If you can keep half an eye on the screen, I've worked with conference technicians who are just phenomenal. They can read the paper, they can do the crossword, and they can just do that out of the corner of their eye, and they just keep everything running. It's amazing watching those guys work, because they've always got half an eye on concentration. True pros. But yeah, you could theoretically do your emails while working on a mixing console if you wanted. So, sample rates and connections. Only channels with the same media profile will connect with each other on Dante controller. So we can have multiple sample rates running within the same network at the same time, and they'll all be synchronous. It's just that we don't do sample rate conversion in a Dante network. So I can't connect a 48 kilohertz channel to a 96 kilohertz channel, which is a good thing because we're now doing video, and we can put video into the same network as well. And you really don't want to be connecting video to an audio device. It doesn't sound very good. So Dante will prevent you connecting video channels up to audio channels and prevent you connecting wrong audio channels to other audio channels. So that's very useful. Remember, higher sample rates give you a lower number of channels for the same amount of bandwidth. You don't get something for nothing. And Dante supports all of the common sample rates between 44K1 up to 192 kilohertz and all the sample rates in between. We also support pull up, pull down for film as well. Theoretically, it's possible to do much higher sample rates, but the market really tails off there. It's not a restriction on the technology, it's a restriction of what people want to buy, as far as we see it. So latency is 100% deterministic. It's always well defined. We've changed this on the new Dante controller. We included this stuff about switches for people who had been using CobraNet previously to have some kind of comfort. We've removed this because now we have the latency monitor, which actually gives you a true view of how fast your network is performing. And that's a much better measurement. It's kind of the difference between taking a system controller for a loudspeaker system and dialing in the meter's delay versus getting your analyzer out and actually taking an impulse response and dealing with what the real delay is in the system. It's always going to be a better result if you measured it. And that's why we've included the latency monitor. Typically, our default latency is 1 millisecond. If you have latency of more than 1 millisecond that is genuinely caused by switches and gigabit switches or faster, let me know. I'll buy some stock in the switch vendor you're about to buy the switches off, because a Dante packet will take about 4 microseconds to go through a switch. So you're going to have a daisy chain of about 250 switches to get 1 millisecond. That's a lot of switch money you're spending there. So yeah, practically the actual real latency on the network is much, much lower than that. We can go up to 5 milliseconds because obviously we're still constrained by the laws of physics. If we want to go 1,000 kilometers, that's about a 5 millisecond delay through a network. We've connected cities together, and indeed we go longer than this. Sometimes we want to connect very, very long distances, and with Dante Domain Manager, we allow latencies of 20 milliseconds and 40 milliseconds as well. In lab mode, I've put some Dante devices into 1.6 seconds latency. That's very strange on a bench. And we can do a minimum of 150 microseconds latency if it's really, 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 really critical. And this is set per device. So different relationships between different devices may have different latencies. So it's important to make sure that your latency settings are consistent within the network. Certainly you would not want to have 2 different lectern microphones set to different latencies, because that can sound very, very strange indeed. You just get comb filtering. So yeah, always make sure that you've set your latencies consistently. So clocking, Dante handles clocking automatically. We use a standard called IEEE 1588, and the master clock is determined by an election, and the criteria for winning this election is well defined in the standard. All of the devices will sync to the master clock, and each device in turn has its own clock as well. And that means that if the master clock goes away, the network can elect a new master clock. And the nice thing with our implementation on Dante is, while that master clock election process is going, because all of the devices are very well synchronized with each other, you can change the master clock and you won't hear that change happen. So leaving it in automatic master mode is actually really much more resilient than having a single master clock device. Now, there are circumstances where you might want a single master clock, of course, if you're trying to do broadcast video and you have to synchronize old-fashioned cameras using Black and Burst with the audio network, sure. I think what's happening, certainly with video and audio together, if you look at the SMPTE standards, SMPTE 2110 for video and SMPTE 2110-30 for audio, both use the SMPTE 2059 standard for synchronization, which is a profile of PTP. So with Dante Domain Manager, we allow synchronization and exchange with SMPTE 2110. So that issue with video sync with audio just goes away. And we can have dynamic clock mastership within the video and the audio systems. So what we don't do with Dante, we don't do sample rate conversion. We don't do level control. We don't do MIDI directly, but there are plenty of software packages out there that let you do MIDI over IP. We don't do 77 timecode as a reader, but there are plenty of implementations where people have read 77 into and out of a Dante network as analog audio, and that works just fine. And of course, SMPTE 2059 is the new timing standard from SMPTE, and that's based around PTP as well. So a few things on using Dante. We have our Dante controller software package, which is our primary Dante routing, setup, viewing, and changing tool. We can make clock adjustments. We can change the sample rate settings of devices. We can change the latency settings of devices as well. And it also gives us clock and latency monitoring, so we can see how healthy devices are in the network. So if no devices are connected to a Dante network using Dante controller is empty. Dante controller always shows the current state of the network, so it's a real-time view. And the key concept here is that the Dante configuration lives in the devices, not in your computer. So you don't need to have Dante controller connected. You can also have multiple Dante controllers connected to the same network perfectly safely as well. So, simple discovery, if we directly connect one device, it will just pop up in Dante controller automatically like this, if you're using an automated system. You can click the plus sign, and that exposes the channel names inside. You don't need to pre-configure anything. In fact, sometimes the most common thing to do is you might have to take your Windows computer and put it back into automatic IP address mode by just saying select IP address automatically if you've been doing something statically previously. We use human readable names, so here we have front of house 1, and for some strange reason someone's using a very unconventional patching technique here, but never mind. But we have the names of the different channels here. A Dante device can be directly connected to a single computer. Indeed, this is how we did this little video. We just took the device, plugged it into the side of the computer, and up everything pops. So if we can use multiple devices and channels, we connect them all into a switch, and also connect our Dante controller computer into the same switch. And the devices pop up on the screen like this. And now we just click the plus sign on a device. And now, if we use the big one here, we can see all of the transmitting devices. And if we click the other one here, we can see all of the receiving channels. So transmission channels are in the horizontal, and receiving channels are on the vertical. So we call connections in a Dante network subscriptions. And we make a subscription by just clicking at the intersection between a sender and a receiver. And we get green check marks when the subscription is okay, and we have audio flowing. So that means it's working. We also have a signal presence light. If you double click the device, it can tell you with a little flashing speaker as to whether you've got no audio, it's grey, good audio, it's green, and if your audio is clipping, it will go red. Getting rid of a route between devices or a subscription, it's just simple. You just go and click again on that green check mark, and the audio goes away. Just like that. You can also do splits. So I can take a single source and split it to multiple destinations. Very, very easily done. I can just decide which channels I want to split. So this channel 1, I can send to multiple inputs of the same or different devices. And there you see we're just having good audio subscriptions, just like that. And it's just simply a case of routing away like normal. And audio will be sent to all of the subscribed devices and channels in this case. So a few housekeeping things. Remember, name the device first, then do the routing. Okay, this is another one of those do as I say, don't do what I do things. Because it's really tempting when you have all these toys just to jam them all into a network switch and for them all to pop up. And then if you have, say, 100 amplifiers, and they've all come from the factory, they're going to come with the manufacturer name and the end of its MAC address. And you're not going to know which each amplifier is. And then you're going to have to go through some difficult way of unplugging it, working out which amplifier is which. So please just plug one thing in at a time and name it, then plug in the next thing, just like you would do with electrical tape and a pen on an analog system. Otherwise things get too confused. Okay? Yes, all right, I don't do that every time and I regret it every time I don't do it. So naming a device is quite simple. We double click on the device and then we go to the device config and we can change this rather meaningless name into something quite useful. Like for example, Stagebox. And then simply hit apply and then it's warning you that there may be an audio interruption because you've changed the name. That's okay, because of course you plugged it in as soon as you unpackaged it, right? And then you name it. Now, we can do channel names as well, so we can see here that this device changed the name to Stagebox. We can change channel labels in a similar way. Double click on the device and we get this device view screen. Go to the Transmit tab, click on the channel you want, and you can change it to a different device name. Sorry, different channel name. And you can see here the signal presence lights. It's very useful if somebody new is coming into the system in a hurry. If everything's labelled up nicely, obviously you know what's going on, just like all nice installations where every cable's labelled properly. Someone said software version of masking tape. I don't know about you, but if someone put masking tape on my desk, I might want to have a few words with them. Adjusting sample rate, very similar. Double click on the device to get the device view, go to device config, and we can change our sample rate to one of the sample rates available on that device. So here we're showing all of the different sample rates that Dante supports. Obviously, if I'm making a device that only supports 48 kilohertz, it would make no sense to have the other sample rates available because it would break things. So manufacturers can restrict the number of sample rates that they support, which is just totally sensible. Power cycle recovery, basically, as I said, all configurations are stored in the devices and not in Dante controller. So that means when I power them back up again, the subscriptions come back up and are re-established. And of course, I don't need Dante controller to be on the network for this to happen. This will just happen automatically. So to reiterate this, does Dante controller need to be on the network all the time? Absolutely not. Don't worry about it. So the key takeaways: Dante controller automatically displays connected devices in real time. Dante devices and channels have user-definable names. Dante controller will display both the transmission channels, the source channels, and the receiver sync channels. And channel-to-channel connections in Dante, we call them subscriptions, and they do look like email addresses. It's channel name at device name, and now we have domains. We have domain as well. And subscriptions are made and deleted by clicking at the intersection between the sending and the receiving channel, and we get a nice green tick there. So, of course, subscriptions can only be made between devices running the same sample rate or media type. Now we have video, and we can adjust this in device view. You can't adjust an audio device to be a video device. We haven't done that yet. Devices remember settings and subscriptions, and of course Dante automatically selects a master clock. And Dante controller does not need to remain on the network for this control to happen. And Dante's uncompressed audio, we don't alter the audio data in any way. We don't do compression and we don't do sample rate conversion. We just take what's given to us and send out an exact replication of it. So a little introduction to recording with Dante Virtual Soundcard. So what is it, first of all? It's a software sound card for Mac or PC. So this is what the control panel looks like. We used to have a round 0-1 on-off switch on it. Apparently in America that's not a standard symbol. And we used to have people asking us, oh, it's not working, it's like you haven't turned it on. What do you mean? The on button. Where's the on button? So after a few years of complaints, we changed it to a little button that says start. It's product development for you. This basically presents audio channels from your computer as normal Dante audio channels that can interact and be routed and patched from and to existing Dante network devices. And you can record and play out from as few as 2x2 up to 64 in 64-ounce audio channels using normal digital audio workstation software. So connecting to a digital audio workstation, this looks vaguely like some kind of Apple Logic type thing. Dante Virtual Soundcard will show up just as a normal sound card. In Apple, we use it as a core audio device, so that will work across a whole plethora of things. In Windows, we support ASIO and also WDM. The WDM driver will only do 16 in and 16 out. ASIO will do up to 64 in, 64 out. And again, it shows up as a virtual sound card, just a normal sound card, and then we can deal with which channels right up to our 64 in, 64 out, if we so wish. So it's just like putting a new sound card into your digital audio workstation. On that side, it's just the same. And on the network side, it's just like having another Dante device in the network. It shows up here, we've got the laptop Memento, and we just have 8 channels available here for patching. And just subscribe them just like it was a hardware device. It'll be absolutely fine. So, a few things about the software sound card. Its minimum latency is 4 milliseconds. It can also do 10 milliseconds latency as well if it's a slower machine. Obviously, it's a software device, so Dante Virtual Soundcard can't be a master clock to the Dante network. You would need a piece of hardware to do that. So that's the constraints of it. A few people have asked, well, at 4 milliseconds latency, well, what if I'm trying to record a band and I'm doing a front of house mix and a monitor mix, and I just want to add the laptop and take a split, and I want to send multicast to them all? Does that mean that the latency of that channel goes up for everybody? Well, it will stick at 1 millisecond because it's easier to record samples in packets than it is to produce them. So receiving, we can receive at 1 millisecond, but transmission will be stuck at 4 milliseconds with Dante Virtual Soundcard. It's not magic, it's just it doesn't get explained well anywhere. So yeah, but you can always use unicast, so you can always use very low latencies between the monitor desk and the monitor wedges, and have a different latency for the recording and a different latency for front of house as well if you wanted. And we'll look at how that works in the level 2 after lunch. So, next steps. If you want to know more, stick around because we're going to do the level 2 after lunch. This goes more in depth onto Dante Controller, more in depth onto Virtual Soundcard. We talk about how to use multicast. We talk about setting up redundant networks and a few other things. For the level 1 examination, just go to this URL. This is also where the slide decks are available from and the videos. So just go to audinate.com certify. If you don't have an Audinate account, please create one, log in, take the level 1 test, and your certificate will be automatically generated. And I'd expect that some people will probably have this out of the way by the end of lunch, I'm sure. So, thank you very much for listening to this.